Now finally, a function is monotonically increasing if for every x and y in its domain such that x is smaller than y, it satisfies f of x is smaller or equal than f of y. Okay, so if I have x and y and I have f of x, then f of y has to be greater than that or equal. Okay, so typically functions that are monotonically increasing look like this. They either stay constant for some time and then grow and then constant and grow, or they could be just growing all the time. Okay? But a function that's monotonically increasing cannot go down. Okay, not. Okay, and the same if a function is monotonically decreasing if, well, we have the other thing. So x and y, we have f of x. Well, f of y has to be smaller or equal. Okay, so functions that are monotonically decreasing they cannot go up, so they is constant, go down, and then constant down, something like that. Okay, we say a function is monotonic, is strictly increasing if these equanities are strict. So this function would not be strictly increasing, but this function would. Okay, so this, for a function that's strictly increasing, it's not never it never takes constant values. Okay? It's always increasing, and the same if the function is strictly decreasing, it's always going down. Okay. So interestingly, when you have a function that's strictly monotonic, this means that the function is injective automatically, as you can see, because if x and y are different, then, and so if y is greater than x, you have f of x is smaller than f of y for a function that's monotonic strictly increasing, right? And this is the same as the definition for injective. If x1 is different than x2, then f of x1 will be different than x2. Okay. So if a function is monotonic, is strictly increasing or decreasing, then it is automatically injective. Okay. And so it says at the end, note that a constant is both monotonically increasing or decreasing, but not strictly. Okay. So this is the same that we have been saying. And so that's it for this part.